is the MD and CEO of Ratio Energy Services Limited. He's an accomplished oil and gas geophysical consultant with over 33 years of experience who has excelled in the business development, oil and gas exploration and production. His area of expertise includes field development, asset management, geology and geophysical consulting, project management, seismic interpretation, and geodata management. He is known for his strategic vision and strong communication skills with a proven track record in securing development upstream assets and expanding into new markets. His professional experiences ranges from his earlier roles at the Geomit Limited, Migos Petroleum Resources Limited, all the way to Shell Petroleum Development Company of Nigeria, all the way from 1990 to around 2008. Within this period, he served in different roles and also worked at the Shell Nigeria Exploration and Production Company. After which he joined Halliburton Energy Services, and now he's at Ratio Energy Services Limited. It is safe to say Mr. Olufemi Adepoju is an accomplished subject matter expert and will learn a lot from his experience. He has significant experience and has contributed to several discoveries in the Niger Delta, the Kwanza Basin, the Lower Congo Basin. He has also worked as a consultant across the globe in Canada, Angola, and here in Nigeria. Mr. Adepoju has a strong technical and analytical skills, and he'll be taking us on the topic revolutionizing the oil and gas industry with AI. Please, a round of applause as I welcome to you our facilitator today, Mr. Olufemi Adepoju, the MD and CEO of Ratio Energy Services Limited. Please take it away, Mr. Adepoju. Nape YP is ready for you.
Thank you very much. Good morning to you all. Well, I've been duly introduced, and thank you for all those glowing tributes. It's nice to be in your midst this morning to share knowledge, to talk about the oil and gas sector. Somebody's raising hand there. Okay, I will continue. So to talk about the industry and to see what is currently happening, what kind of challenges we face. And I must tell you, we face a lot. And then to see the conventional ways we are using to face these challenges, to solve the problems and the issues, and then to now also see how we can do things better. Do things better with technology, do things better with science, do things better with the fact that people are going to the space like as if they are going on a holiday now. It's so easy now. If you have the money, you can just book a shuttle, and the next minute you'll be in space. So that's how far technology has gone, and it's good that we in the industry also are thinking of how to make things better. I will tell you that virtually all the service providers have gone back to their research centers, and all of them are competing now to beat each other to be the first to fully deploy AI technology, machine learning, and things like that. So these are things we'll be looking at we'll be looking at changes, that we should expect that's going to come as time goes on. Let me share my screen with you guys again. Yeah. It's unfortunate that I couldn't get to show on on um, on a video mode. But can you see the screen very clearly now? Hello, are you seeing my screen very clearly? And are you
Yes,
hearing me
I can
very
see your,
clear?
and I can hear you clearly also. I want
Okay.
one or two persons from the audience to also confirm they can hear me and they can hear you and they can see your screen. Yes.
Yes, sir, I can see. I can also
Oh,
hear your voice clearly.
okay, all right. So the next thing
Yeah,
I will say,
I
the next thing I
can
will,
see this,
okay,
but
thank
can
you very
you
much.
in a little bit or put it in PowerPoint mode so it will
Well,
be
that's the
clearer?
point. I put in PowerPoint mode, and it wasn't sharing. I don't know why, but let's try one more time. Now you can see it nice in PowerPoint mode now, but I understand when I go to the next slide, it doesn't show. So can you tell me whether you can see my slide now, whether it has moved?
It hasn't moved from my hand, so I don't know for others though.
So that is the problem
Same
I'm
here.
having. So let's see.
Okay. I think, sir, we will continue with the initial plan. We'll continue
Yeah, I
from.
don't know what's really going on there, but let me see. I tried, I couldn't. So it's not working. Unless I connect to a dual screen, which I don't want to do now. But anyway, if you can see it now, that is let's manage this. I wonder why it's not scrolling, but here it scrolls. But so we all know the what the oil and gas sector is all about. We are working in it, and it's a crucial sector that has been sustaining the economy in terms of the fact that it provides energy needed to power economies and support our modern lifestyle. Yeah, anywhere you want to go now, it's anything you want to do virtually is the oil and gas sector. We recently had an increase in the petrol price. Virtually all petroleum products, from diesel to jet A fuel, to petrol to kerosene. So we see the impact it has, on our lifestyles. So it's a crucial sector, and for us in Nigeria, is our main foreign exchange earner. Is the main foreign exchange earner. So yeah, all the dollars we are spending, I will tell you that maybe 60, 70, 80% comes from the oil and gas sector. So it's a sector that we have to really protect, guide jealously, so that we can, like you say, support our modern lifestyles. Now we can look at three major sectors in the oil and gas industry: the upstream, the downstream, and the midstream. So the upstream will be mainly the exploration, development, production sectors. And in your exploration, in your exploration development, you have your acquisition, processing, interpretation, well drilling, facilities, pipelines, the entire stuff. So that's the first set of division you're looking at. People who really go to bring this oil out, and when the crude comes out, we're looking at how to refine, how to separate, how to treat, how to market. So those are our colleagues who are in the downstream section. And then, of course, you have to look at how to store what you have refined, how to distribute it. Yeah, those are the guys in the midstream. And I must tell you that department is one of the very crucial departments in the entire value chain. We have experienced petrol queues and things like that, yeah, all over. So it's a very important aspect of the business, yeah, in the value chain. And of course, the more important ones, we'll see talk more about this anyway, is the safety aspect, HSC, security, and then sustainable development, and then getting alignment with our stakeholders. Those 3 or 4 points are very, very important. And we all know how challenging it is now to operate in the Niger Delta. It is very, very, yeah, challenging. If you have to go in, you have to go in fully ready, fully prepared. If you are not, you will not be able to operate at all. So it's an important aspect. So I'll move to the next slide. Like I said, if you have any issues or questions or clarifications, just put on your mic, stop me, and then we can discuss it. I don't want us to be talk, talk, talk. I want it to be as interactive as possible. And if there's any issue you want to raise it. We'll discuss it. We don't need to wait to the end of the presentation. So let's see what we are going to talk about today. We are going to look more at it, the importance and
Hello, sir.
capability of AI. Okay, yeah, go ahead.
Yeah, sorry, sir. The plan is for you to run, and we'll ask the questions at the end of the program, if that is okay by you.
No, that's okay. That's okay by me. Yeah, that's okay.
Thank you very much.
So basically, we are looking at how to improve efficiency and productivity. Then how to look at decisions, how to make decisions based on data that we have, not just whiff of the hand and just guesswork or whatever. Those of us in exploration, we know this. If we want to generate the geological chance of success for a prospect, we need a lot of information, and it's the information that is going to drive your decision. Yeah. Of course, we're looking at innovation and adaptability. How can we come with new ideas, new ways of doing things, yeah, and then apply this? The next thing will be, how do you manage your risks? Yeah, and then of course compliance with all government regulations. So there's this a myriad of so many things that interplay with each other that we are looking at. And then what of customer experience and sustainability? How long can we sustain what we are doing? And then cost reduction. How do we reduce costs? Yeah. How do we become more efficient? How do we reduce costs? So we'll talk more about all this. And of course, we'll be looking at what is machine learning, computer vision, speed recognition. So there are so many capabilities of artificial intelligence that we'll be looking at here. So for the challenges that I've mentioned here, we see that innovation and technology are very essential for overcoming these challenges. Some of them, I'm going to list them again: resource depletion, carbon emission, cost reduction, environmental impact. So all the day-to-day challenges we face, how do we resolve them? So we'll be looking more at this. Now, what is AI? It's artificial intelligence. That's the full word for it, the full name. It refers to the simulation of the human intelligence in machines. Is worth thinking about. And I will tell you guys, this is where the future is going. The other day I was sitting in at the airport in Amsterdam. Yeah. Unfortunately, what Donald Trump called black jobs. those black jobs are disappearing fast. If you know what I mean by black jobs, it was a machine or some set of machines that were cleaning the floor, yeah, and collecting the plates and the garbage at the airport. You never see any human being doing it anymore. And if you are standing in their way, they will talk to you, they will interact with you. Can you pass a plate? Can you move aside? We want to clean here. Everything automated, robots doing it. Yeah. So more of these are coming. And in the near future, what we are going to have will be machines that will clean your house, machines that will, cook your food, machines that will serve you, and machines that will do everything. So people keep saying the jobs will be taken by machines. Well, I will say yes and no to that. We'll talk more about that also. So these machines are programmed to think and learn like humans. They make decisions and they solve problems autonomously. So that's the future now. The machines are going to come, robots are going to come, and basically what it involves is writing code for computer system to make them explicitly perform tasks that demand human reasoning. Yeah. So they are going to be able to reason and take decisions and say, oh, do I go right? Do I go left? Yeah. Um, you see, so many areas now have started developing this. Some of them we have been using, like artificial neural networks, to perform more complicated human tasks. So neural networks can even do better, yeah, than human beings. I play chess a lot. I don't know if any of you guys play chess. You can play a computer. You can play. Your opponent can be a robot on the computer, and the basic algorithm they use are neural networks. And I bet you, if the depends on the level of intensity you are playing, you may find it difficult to defeat the computer. Yeah. So it's some of them can reason more than the average being. So that's where we are going. And of course, you have the natural language processing, which involves creating software to interrupt human communication, to interpret human communication. So we have that one going on now. I mean, if you go to all these international meetings, United Nations and whatever, what have you, uh, somebody is speaking either in Chinese or his own language, and automatically what you are hearing is in your own language or your preferred language. So if a Chinese man is talking and you want to hear it in English, for example, yeah, you just press a button, and what he's saying is going to be coming to you in English language. If you want it in an African language, which I hope for also, you're going to be having it in Yoruba or Igbo or Hausa or wherever. So that's how far technology has gone. Now, the one I mentioned before was robotics, where I said the deployment is going at a steady race now, a steady pace. Where I was in First Bank the other day, the one in Victoria and there, and there was a robot there that was welcoming people. You are welcome. You are welcome. And then yeah, that's what you just see. But it's so programmed that when it senses that someone is around, it's going to talk and welcome the person to the bank. So it's coming. We'll be seeing more of this. Now we talk more about machine learning. We compare it to what artificial intelligence is, and we see how a huge chunk of AI is performed using machine learning. People use them interchangeably, but it's good to have an understanding of what each one is. So AI, um, it will make a machine display some human behavior. Yeah, it will display human behavior like like the robots I told you about. Yeah, that's AI. And then also, you go to some websites, and then you want to interact with the people behind the website. You will see a robot, hello, can I have your name? You welcome. What can we do for you? Then yeah, you interact. We interact with that, and then you get some answers. Also, most of the time, you pick up a phone. Yeah, it's a robot that is talking to you. Press one, press two. Do you want to deposit money? Do you want to withdraw? Do you want to do this? You want to do that? Yeah. So that is artificial intelligence at work. Machine learning does that, but machine learning keeps growing because it's going to automatically learn from all the data it's gathering. It's going to learn and become better and better and better. You'll be able to make some predictions, yeah, from the historical data it's carrying. Yeah. Artificial intelligence revolves around humanizing smart computers. So basically, what it does is to make your machine or your computer smarter. Yeah, to be able to do some basic programmed activities. It's going to do that. Yeah. But machine learning, we learn from that operation. Yeah, and deliver an improved output. So machine learning keeps putting all the data together. The more the data it's got, the better the output is going to be. For artificial intelligence, of course, the chance of success is high because it's programmed to do a specific thing. But for machine learning, it's more about patterns, It's more about patterns, and it keeps getting better and better and better. So that's why machine learning is better. Yeah, it is. Yeah, what we really need. Now, artificial intelligence involves learning, self-correction, and reasoning. But machine learning revolves around learning, self-correction, only when data is provided. So you need to keep feeding machine learning more data, which is why it is good for us in the industry. And we'll talk more about this, one of the challenges we have in the industry. Now, for AI and ML, the major programming language is Python. Yeah. And we'll be presenting, we'll be having a discussion on what we have used Python to do at Ratio. We have been able to build a machine learning algorithm that can generate logs that are not available in a well. If you have your Sonic log missing, for example, and you have other logs available, you can use machine learning to generate, that missing log based on the existing logs. It's going to look for patterns and ways, and then generate that for you. And we have done this with the algorithm we generated. We observed that the results are better than what you have in all these commercial software, like maybe Petrel or Decision Space or whatever. So each time we are working for any of our clients, that is what we bring forward. And you say, look, we'd like to demonstrate to you that this algorithm we have here is far, far better than what you are getting. Yeah. So why Python is still the best is that it's got a very nice, fantastic library. It's got good community support, and a lot of other benefits also. Yeah. Okay, let's look at the next slide. So I mentioned this one before. AI has so many different branches. You can start from deep learning, I mentioned that before. Neural networks, convolutional, I mentioned that also. You can now go to supervised learning, unsupervised, reinforced learning. So these ones for machine learning has always been there. We've been doing this here. But now for artificial intelligence, the the learning is even more. There's optimization, there's planning. So it's getting better and better. So that's what this slide is showing us. So conventionally, these are the issues we have been battling with in the oil and gas sector. Operational costs. The unit cost of production in those days used to be less than maybe $4, $5, $6. But now most of our operations we're having for each barrel of oil we produce, we are spent between $20 and $30. That's quite a lot. So the costs are shooting up every day. Of course, we know the reason why. I mean, cost of living is rising, more people to do the work, and longer delays, and things like that. Yeah. Moreover, the environment itself is getting more and more complex. Onshore before, I mean, your simple rollover anticline and the simple traps have all been drilled, yeah, onshore. So we are going for non-conventional place now. We're going for non-conventional place. So we are looking at a deeper opportunities. So that costs more money to go down deeper. We are going far offshore now. Yeah. So we all know that most of the IOCs, they have left the onshore place now. They are going deeper offshore. Yeah. So the complexity is increasing. So that is why the challenges have increased also. Of course, our carbon imprint, yeah, the carbon footprint has to reduce. There's so many regulations on this, so it's got to go down. Yeah. Then the other one is good we have young people like you. Old guys like us um, are doing other things now. So we are losing a lot of expertise. A lot of people say, well, I just don't want to do this business. I want to take a break. Yeah. So younger guys are coming and they need to learn and learn very fast. They need to learn very fast to fill that gap. Yeah. That gap is still there. Yeah. You know that recently most of these IOCs have been laying off staff, and then most of the staff they just say, "Well, I don't want to come back to this industry again." So there is a depletion of experienced personnel, and that's one of the big challenges we have now. That's one of the big challenges. A lot of people don't want to come back to the industry again. Yeah, I hope you know that Shell is also trying to divest from onshore. They are giving other companies, Nigerian companies are picking it up. And the idea is that the existing personnel will stay on. But that's just, an aspiration. It's just a hope. What if they say, well, we don't even want to do this anymore? So the new company will have to start, looking for younger people, which is okay, and start training them fast. Then the other challenge, which I think is the major challenge, actually these last two challenges are the major challenges we have. HSE, security, sustainable development, license to operate, stakeholders, and risk management. I mean, in those days when we were, when we were in seismic or when things were good, you could just go to any community and they welcome you. You carry out the operations, drilling, seismic, interpretation. The host communities were very friendly. Well, that's not the situation now. I don't need to push more on this. That's not the situation. So you need to secure your license to operate, and that comes at no easy cost. You have to secure a license to operate. It's not easy at all, and we have challenges with sustainable development. We have issues with security. In fact, we even say that's the worst. When people tell me that there are still some companies acquiring seismic, I just pray for them because a lot of our personnel have been kidnapped. We have lost a lot of lives, So security in our areas of operation is becoming a big issue. Yeah. So HSE also, the rules are tighter now. Yeah, for environmental degradation, health and safety. So there's a lot of challenges we are facing here. And the other one is the infrastructure itself. Infrastructure, that is a big one. I mean, most of these pipelines we have now are more than 50, 60 years old. Yeah, some of them are rupturing. Some of them are being ruptured. A lot of spillages here and there. We have a lot of oil spill here and there. So it's getting more and more challenging. So we have to start thinking of how we can, do things better. And that is where artificial intelligence and machine learning comes in now. So let's look at some of the areas we can face these challenges, yeah, and overcome them. We can use AI to create advanced research and production technologies. We can use it to optimize our field development plans, thereby reducing risks and increasing drilling success. All the risks we have in discovering new reserves, that these are the risks in exploration and production. So this can be minimized by AI. We'll talk more about this. Now we're looking at automated drilling platforms and intelligent drill pipes to improve quality and. Now there was a video I saw. I think it's in Minnesota or wherever. You just call your Uber or call your Bolt or any of these taxi service providers, and the vehicle you are going to have is going to be a remote vehicle without a driver. Yeah, everything has been programmed into the car. The car will interact with you and take you to where you are going. Yeah, that's number one. Now, the cars they are making these days now are more or less AI driven also, which makes it difficult, very difficult for you to have an accident. Yeah. Now, if you are changing lanes without using your indicator, light indicator, your car will not move. It won't go to that lane. Yeah. So they have it in the Toyotas and the Nissans and all these other cars now. Your what's it called now? Yeah. What is your new cars now? So they have them in now. So if you are about to reverse, yeah, or to even go and hit something, the brake will apply automatically. The car will stop by itself. So it's difficult for you now to say you want to drive into a wall. The car will stop, yeah, before it hits the wall. So that's AI, being close to us. Yeah. So as we go on, we started having things like automated drilling platforms, intelligent drill pipes, and what you just need on your rig now will just be maybe the drilling supervisor and a couple of people. Everything is going to be, everything is going to be drilled, using AI technology. Yeah. So what we need as we go on will be how to get our data organized, because that's the main issue I see. We are sitting on a lot of historical data, which is good for machine learning, but now we need to put them in an organized manner so that AI can use them efficiently. And in this one, I'm talking about artificial neural networks, which are commonly used for real-time applications like when you are drilling, you want to know your rate of penetration, you want to know the drilling performance, what decisions has to be taken automatically and things like that. So AI also now, we'll talk more about this for our geological interpretation and other things. AI is coming in strongly. And I keep telling people, just like I mentioned before, the way we do our reservoir evaluation is going to be different within the next, within this year. It's going to be different because I know that our service providers are working on AI-driven seismic interpretation, static modeling, dynamic modeling, and all the stuff. So everything is going to be, we'll talk more about that anyway. Everything is going to be on one platform. Yeah. You do your interpretation, you do everything there, and AI picks it up and generates your reservoir models and even goes ahead to do the dynamic modeling for you. Yeah. So let's look at the next slide. So let's start looking at some of the applications now. Predictive analytics, using AI to analyze geological data and predict locations of oil and gas reserves. So this is where we are going next. Yeah, the next set of commercial applications that are coming out, we have more of AI. We have more of AI. It's there, but it's still not much. Yeah. If you look at the third bullet point there, maybe I will talk more about it. Seismic-driven 3D models. So what we have now is you interpret on seismic, then you take it to the modeling, your horizon, your fault, to do your structural modeling, your facie modeling, and then your reservoir, your property distribution and everything. And then when you finish, you give the whole thing to the reservoir engineer to do the dynamic simulation and come up with your production forecast. This is so good, but it's going to change. So if you want to do an FDP that takes maybe 1 year or so, with this, within 6 weeks, you have your FDP ready. Because what happens is that the machine is going to do everything for you. So your seismic volume, is going to be, your seismic volume is going to be your 3D model itself. Because it's in 3D, it's in time, it could be in depth also. So you can easily convert to depth, put your fault segments, then interpret your faults, interpret your horizons. That's a 3D grid itself. Yeah. So that is your structural model in a way. Yeah. Then you cannot build your facie inside that seismic, bring in your well data. Yeah. And then it's going to generate the facie for you and use the seismic to distribute it. Yeah. And all the other things you are going to do, the inversion, the AVO, all those ones, when you have vetted the volume, is going to be also AI driven, machine learning driven. So that's why I say it becomes more efficient, it's going to become more timely, and then, and as it's doing it, it's learning more and more. Yeah. So we're going to be having the algorithms to process the seismic data and create detailed subsurface maps, improving the accuracy and reducing exploration costs. Now, the one I mentioned about is the dynamic modeling, the fluid dynamics, the fluid behavior, and how to improve recovery rates. So from that, your model, what you also do is to bring in your production data, historical production data. So it's going to do the history matching for you, and it's going to predict the fluid behavior. It's going to do the fluid behavior for you. Yeah. So we have case studies. BP currently is using AI for seismic data analysis, and that's leading to more and more efficient exploration results. So it's ongoing, but it's going to come out better now. Yeah, because like I said, all the service providers have gone back to their research laboratories, and they are bringing more and more things in. So let's see further areas to this. Seismic interpretation, reservoir characterization. I just mentioned that. Drilling, I've mentioned that. Production optimization, reservoir management, risk management, and decision support. Environmental monitoring and compliance. We'll talk more about this, yeah. So AI is revolutionizing exploration and production processes in the oil and gas industry through these applications I just mentioned. It's not there yet, but that's the future. It's coming. Now we have some details here for reservoir identification. For example, we have some seismic facie classifications using basic seismic data facie identified and labeled based on known geological features such as sandstone, shale, whatever. It can do all those ones. And this one improvement reduces the uncertainties when working with large volumes of seismic data. So the more the data we have, the better for us, the more predictions we can have. Yeah. So the same thing goes for a prediction of pseudologs. So we're going to make a presentation on this one. Like I said, we are very good at this. We have our own algorithm for doing pseudologs. We'll talk more about that. Others are the generation of electrofacie, pore pressure prediction. So pore pressure prediction now cannot go on without the application of AI and the machine learning. Yeah. So there are a lot of regression models. And then based on available well logs and velocity information, AI will integrate those diverse data to reduce uncertainties and then lead more, give us more accurate predictions. So we have a couple of papers we presented at Nape, last Nape on this. So I will get my colleague to talk about the generation of pseudolog, the one we used AI and ML to do. So it will take you through the processes. Hello,
Hi,
I
good
hope you
morning,
are on.
everyone.
Oh, yeah, good morning.
Yes, and I hope you can hear me. Good morning. So I will start by saying that kudos to the industry-based softwares that we have, the Petrel, the Techlog, the Geographics, and the likes. They have all incorporated machine learning into their software, one way or the other. If you want to, the static modeling method that we was talking about before, if you want to do that in Petrel, you use your sequential Gaussian algorithm, SGS, or sequential indicator in the algorithm to distribute your fascists away or your properties away from the well. These algorithms are machine learning based. So it's not like this machine learning is entirely new to the industry. Just that it's about to go advanced, or it has been going advanced and it has been increasing. That the computer continues to learn, just like it is, continues to learn and continues to be better. So one good thing, especially in Niger Delta here, is that we have a lot of well data, and seismic data. And with these, there have been trends like you can have GR trends of things of wells in Niger Delta. So my trends can be based on GR, Sony, and the likes. So if I want to work on a field in Niger Delta, maybe the field is in Greater Ogilvy Depot Belt, for example, and I want to predict GR logs, all I need is to look for wells around Greater or around the block I am working on within the Greater Ogilvy Depot Belt and use this to predict. So TechLog in particular, which is mainly for petrophysical evaluation, has been doing this. We have even Petrol does that, but TechLog does that better than that. So with TechLog, we have been able to use this machine learning algorithm. But now the challenge here is that we cannot control what TechLog gives us, especially the neural network algorithm in TechLog. We just give it our data and then it gives us the result, more like a garbage in, garbage out. Of course, we trust the algorithm process, but because we want to reduce risk to the barest minimum, we want to reduce it to the least. We want to be sure that, okay, this is the process it is running at the back end of it, and the result is giving us is very accurate. We need to now keep seeing the result. So what our petrophysicists for this paper, what our petrophysicists initially did was to use the neural network algorithm in TechLog to predict for the missing log. Because the challenge is that we have three fields in this particular study. We have three fields. Field, I'll just for confidentiality's sake, just call them field X, Y, and Z. In field X, we don't have sonic log, but in field Y and Z, we have sonic log. And we know that for us to have a proper well to seismic tie, we need a sonic log and a density log. So the sonic log for about 30 something wells, there is no sonic log. It is missing. Maybe when during the acquisition of the transfer of data from one company to another, because it's a marginal field, the sonic log was not provided, and they are unable to go back to the company and say, hey, where's our sonic log? So we need to now predict the sonic log for this field. Now, when TechLog predicted the sonic log, it gave us something. Well, no, TechLog also we can also use Faust and Gardner's equation, and also I think regression and neural network. When we used all these methods, the results we were getting, comparing it with the the data from the other or from the Niger Delta generally, you see that it's not really consistent. It's not what we want. So we had a little bit of challenge with that, with accepting the results that the software is giving us. We tried, okay, is it that we are not doing the correct thing? Is it that we are putting the wrong constants? Is it we tried multiple things and the results if we can go ahead with the results, of course we'll get what we want, but we want something better because we want to be very especially when it comes to our velocity model. We want to know the exact steps. We don't just want to our variation or our residuals to be too much. We want to get something very, very close. So this made us go to Python. So when we interpreted what TechLog has given us with Faust, Gardner's neural network, and we kind of do a data analysis to compare with the original logs. We see that the software has kind of skewed our data. So instead of our Sonic being within a particular range, we don't have it within that range. Also, when we try to predict the logs that we know, okay, we have, like I said, we have Sonic logging well set. So let's try and predict a Sonic log for a well in set. You see that it's not very consistent. Of course, it is, we have it to a certain degree, but it's still not very reliable. So Python has a lot of algorithms, Skylearn, free flow, a lot of machine learning package that we can use. So we imported our data into Python, the well logs now. We have GR, we have depth. You know that Sonic relates to depth also. We use GR, we use resistivity, and we use neutral. So we use these logs now to predict using I think scikit-learn. That was the major package that was used for this prediction. And also there are a lot of Bayesian regressions and a lot of that were Python. So the machine learning process is basically okay. We have wells in field Z and Y that are sonic log. Let us predict sonic log for these wells that we already know the sonic log. We already know the how the logs look like. We have an original log. So we try to use Python to predict for these particular wells that we already know the sonic log, and we see a very high correlation coefficient and very similar pattern. We have about 90% correlation between the predicted log and the original sonic log. And this made us have a greater comfort with what Python is giving us. 90% correlation. Then we'll go away from the well, away from the field rather, between field Z. Now we'll go to field Y and we'll predict the sonic log in field Y. Then we're getting about 80 something percent correlation, which is still very high. So it means that if we go to field X, which is a little bit far away, with our data, we'll have lesser correlation, but at least we have higher confidence based on the fact that we are controlling this method. A lot of processing will go into it, test our test data and our results. A lot of things have gone into it. So we are the one in complete control. It is not a third party software that is just garbage in and garbage out, which have been good. But in this one, we have very good control over it. So with this now, we compare. We still did not ignore the software. We did not ignore their results. We now use these results and compare together. And when we compare together, we plot them on the same scale in Petrel, and we see that the ML result is having greater trend. It is giving us greater correlation with the trend, as we expect that the sonic goes with depth. That is the same thing we are seeing from the predicted log. Unlike if you see the in pictures 7 has predicted sonic log comparison, you see the rightmost log there. That's the kind of, is it purple color or pink color now? That color is very deviated from the original. I think that's Gardner's equation, what the one we got from Gardner's equation. But the machine learning, which is the one in the leftmost, is almost lying on the original log, and they are on the same scale. So we have the original, we have the predicted, and it is almost lying on it in literally all depth, and it is following the same pattern. So this boosts our confidence that okay, what we are getting in machine learning is better than what this software is giving to us. Then we now use it for our synthetic seismogram. Of course, synthetic seismogram also has its own uncertainty and its own specialty. You need to know how to stretch and squeeze, in order not to have a great stretch to have your perfect correlation coefficient. So we did this, and then we saw that with machine learning, even without much stretching and squeezing, the sonic log that we got from machine learning is already giving us high correlation coefficients compared to the other predicted logs. So this boosts our confidence in this. Now, this is just a pause in this project because where we are going to, of course, we know that a lot of research has gone into getting trends of logs in Niger Delta. The place we want to get to is to be able to get, okay, we want a particular location. We have a particular location XY in Niger Delta, and we want to predict log for this particular location XY. And then we have seismic data for it. We want to be able to predict log without with using just our seismic data and then the offset data within the field. So let's say it's a brown field where there is no well data at all, or maybe just very few data, or maybe one well data. Then we want to predict logs for other locations. We can't rely on that one well data that we have. We want to use our seismic to be able to predict well log with depth. That is the point we are getting to with this research. And that is one of the things that we are doing at Ratio to improve uh, our, the results that we are giving to our clients. So that will be the end of my presentation. Thank you very much.
Thank you very much, Solid. So I will continue the presentation with how we can improve our operational efficiency. With what we have now, AI can predict equipment failures before they occur, thereby reducing downtime and maintenance costs. We'll still talk more about this also. Yeah. So AI powered maintenance monitors equipment for wear, allowing timely repairs to reduce failures, downtime, and cost. And for HSC, good news. There is prevention of accidents through detection of hazards in real time. So the safety systems also monitor employee behavior, ensuring compliance and safety protocols. Now, integrating AI into maintenance and safety practices improves overall industry. Now, there was a question that I asked myself the other time, which I'm sure people will want to ask. With AI, what's going to happen? Are we going to lose people? No, we are not going to lose people. We are just going to change the way we work. That's just what is going to happen. We are going to change the way we approach our operations. Now, look at a couple of things we don't do for HSC, for example. This will just be a typical example. We are supposed each and every day to monitor in real time and record in real time near misses. If you have near misses, you have unsafe acts, unsafe practices, yeah. And then we see some hazards, either trip hazard or electrical or whatever. We are supposed to have a database of all this, which we are going to feed into our system. This requires a lot of human interference, human input, So the machine will not detect hazard for you, no, but you need to feed the data and then now program the patterns, program what, it's supposed to do. So the moment we have this in place, the system will now start monitoring what is going on, start learning and start building and start taking decisions, So you don't, the more you keep doing this, the safer, we become, and the more we see the improvements. Same thing goes for supply chain optimization. The entire logistics, down the chain, so that we can reduce the delay times in maybe delivery of materials and other items. This really reduces costs a lot. And then real-time monitoring. We can train our system to monitor operations in real time, and be able to take quick decisions, responses to issues, and then improve our performance. So currently, Shell uses AI for predictive maintenance, resulting in significant cost savings and increased equipment reliability. The next area will be safety and risk management. We have spoken about this. Hazard detection, in real time, preventing accidents, and then risk assessment. AI will evaluate the risk and provide recommendations for mitigation, thereby improving overall safety. And there are a lot of AI-driven tools we have now, like drones and robots to perform inspections in hazardous areas, reducing human exposure. So instead of sending people to say, okay, let's go and do this audit, fine, it's okay, we can do that. But there are some areas that the machine will see better. I mean, a drone will have a sky view, a helicopter view of what is going on, and record the observations, for improvements. So those are real live situations we are seeing here. Chevron uses AI for risk assessment and hazard detection, enhancing safety protocols. So these are real applications that are in place, but improvements will improve with time. Environmental issues also, reducing the carbon footprint. I mentioned this before. How do we reduce? It optimizes energy use, thereby reducing emissions, contributing to a smaller carbon footprint. Waste management also, recycling processes, are managed more efficiently, minimizing environmental impact. And the compliance with regulatory standards, it does that also. ExxonMobil currently uses AI to monitor emissions and improve environmental compliance. So you have a machines put in place, taking measurements, every minute, every second, yeah, and recording it, and then plotting graphs and taking decisions and things like that. For drilling and completion, we have in real-time drilling optimization, geosteering and well placement, formation evaluation, characterization, casing design, fluid management. We mentioned the safety and risk. So these have been ongoing, yeah, but the process is being improved. Like I said, the main thing is, data collection, how we organize our data, how we feed it into the system. So in the production optimization, the same thing. Predictive maintenance in the area of asset management. Yeah. So these two areas are very important. We just mentioned the supply chain optimization, inventory management, logistics, ensuring timely, delivery and cost efficiency. And then for demand forecasting, AI will predict the patterns to optimize the procurement, distribution process, to reduce the long delay times, all these long lead items and things like that. So let's quickly look at companies that are successfully implementing AI. We mentioned about BP, seismic data analysis, leading to more experience exploration. For Shell for predictive maintenance, resulting in cost savings. Chevron in risk assessment and hazard detection. ExxonMobil for monitoring emissions and improving environmental compliance. So these are best practices and insights, from this implementation, so that the lessons learned, improvements and improvements. So what are we going to look at in what's the trend going to be like? So we're looking at things that will come like edge computing, quantum computing, autonomous systems, things that will be working simultaneously at the same time, performing more and more complex algorithms and decision making and things like that. Yeah. And then energy transition. AI will come in how to reduce dependence on the fossil fuels. So AI, as it is in our industry also, is going to be in the, in the in the renewables. It's going to come in the renewables and pick it up from there also. Yeah. Now, in our predictions, we are going to have better predictions now in what we do, either in our production forecast or our geological modeling, geophysical interpretation, wherever. So we're going to be able to, with the increasing volume of data we push in, we're going to be able to have better predictions. Now, I'll quickly go through the paper we presented last year, Nape also. Yemi has given one, so I'll give another one, which is also based on machine learning, There are some uses here, which we have mentioned before. Optimizing web placement. ML can be used to analyze historical production data, reservoir properties, seismic data to identify optimal locations for new wells, which of course will lead to significant increases in production and reductions in drilling costs. Now, for our G&G people, identifying new reservoirs, machine learning will be used to analyze the seismic well logs and other data, integrate them to identify new oil and gas reservoirs that may have been bypassed using traditional methods. So in this one, we're talking about quantitative interpretation, AVO, inversion, and things like that. Yeah. So this definitely will lead to new discoveries, yeah, and increased production. Now, reservoir characterization is mainly driven, yeah, now by AI and machine learning, and this is going to continue to increase. The involvement is going to be increasing, yeah, helping engineers to better understand distribution of oil and gas in the reservoirs. And then our prediction also, I mentioned prediction for using different production scenarios. So it's going to, in the next couple of months, we should see an FDP taking just within 4 to 6 months. You should finish your FDP. Now, the methodology I mentioned is data collection and preparation. So this is where the human interface comes in now. We need to collect and prepare our data relevant to the primary recovery process, such as historical production, reservoir properties, seismic. They need to be in a very good, usable format, And then the system will be able to extract the features from the data that are relevant, for the primary recovery process, such as porosity, permeability. So the data should be in a format that is easy for the system, to pick and use. And of course, we are going to, the more data we have, the more the training, we train the data and then the model, to give us better predictions. So the deployment is it's on, but it's going to increase. That's the future. It's going to increase. Yeah. So we have discussed some of the benefits, so I won't waste much time on this. Basically, improve production, cost reduction, improved HSE, reduce all our risks and uncertainties. So overall, is a powerful tool that can be used to significantly enhance primary recovery of our oil and gas. So let's see some of the results we're having, and the things to do from now on. The research that is going on are very promising, and it suggests that machine learning has come to stay. It's got a potential to play a significant role in enhancing oil recovery. But there are some challenges and limitations, like I mentioned before, which we should reiterate again. It requires a large amount of data to train. So this can be a challenge for oil and gas companies that do not have access to large data sets. It's also a challenge for oil and gas companies that have large data sets that are not well organized. Yeah. It's our entire data handling needs to be improved to take advantage of this technology. Yeah. Now, the models can be complex and difficult to interpret. Yeah. So we need to spend more time on it to make meaning from what the system is giving us. Yeah. Sometimes it can be biased, yeah, depending on the data we're pushing. So definitely you will get inaccurate results. It's garbage in, garbage out. So we ourselves, we have to see that we populate our database with the best data, and make sure that any data that is misleading is not used in the training process. Yeah. But despite these challenges and limitations, machine learning has come to stay. It's going to revolutionize the oil and gas industry. It's doing that already, but it's going to get bigger and bigger to enhance primary recovery, to improve the efficiency and profitability, yeah, of the industry. So conclusions, this is my last slide. What should we do? We should start investing in data collection and preparation. I can't mention that over and over again. The models require large amounts of data to train, and they require good quality data. So it's important, that we invest in collecting, collating, preparing data relevant to the, process we want to carry out. Data, data, data. Then we ourselves have to develop expertise. Yeah. So we need to develop expertise. Yeah. And get people trained, get people to know what to put in. Our universities, we need to, and research institutions, we need to encourage them. I know they are doing a lot, yeah, but we need to reach out to our institutions of higher learning to see what they are doing, and what, machine learning algorithms they are generating. Now, this other one is very important: share data and best practices. Um, it could be a challenge for companies that are competing, but on the long run, I mean, organizations like NUPRC that is sitting on a large volume of data should come in and talk to our different companies. There should be a common database somewhere, yeah, that we can use, to build a strong machine learning based set of models. Yeah. So by following these recommendations, the oil and gas industry can accelerate the adoption of machine learning for primary recovery, enhancement, and realize the significant benefits that this technology has to offer. So thank you very much. There is a lot more coming with machine learning and AI. And like I said, we are just waiting to see. It's going to really change the way we do things in the industry. So we all have to get ready for it. We all have to we all have to be there when it comes. And the fear that it's going to take jobs away, no, it's not going to take jobs away. Rather, it's going to change the way we work. And it will even bring in more. We need more people to handle our data, to synthesize them, to clean them up, to do everything. So it's going to bring more people in, and it's going to change the way we do our work. Thank you very much.
Thank you very much, sir. Mr. Fede Boju, the MD, CEO of Ratio. Wow, that was incredible. I believe we all had fun. We all enjoyed ourselves. We learned a lot. I'll give you a summary of what in this session. So, Mr. Deepu gave us an overview of the importance of AI in the oil and gas industry. He also made emphasis that AI has come to stay. To say, as an individual, you need to develop yourself. Become interested. Where we talked about identification, assessment, identify the hazard not the too many in order to achieve a quality assessment, security and safety of our production sites, the individuals, production optimization, inventory management. AI is also being able to forecast productions, loss, identify hazards and other scenarios, also improve the tactics in our supply chain. And when it comes to the technical aspect, seismic analysis, wow, that's a big deal because we all know that seismic is one of the most important data sets for oil and gas exploration. So fault interpretation, horizon interpretation, AVO analysis, all these are aimed to identify the reservoir, the surrounding environment, enable production. At the end is to improve the company's asset, improve our daily lives, make life easier, provide support. And the major takeaway from me is that it reduces the time management, which is what the clock is about. It's something that is not within our control. So time management, very, very, very important. And AI can help us optimize our times. That is a wonderful presentation. I know we all have questions. Please a round of applause again for Mr. Femi Adipodi. And if you have any questions, please indicate by raising your hand and I'll pick. Do we have anybody that wants to ask a question? Oh, yes. We have someone already in the chat. Please, if you also put your questions in the chat box, we'll also take it from there. I want to also appreciate Mr. Lufemi Adepoju and his colleagues and the entire ratio for taking their time and investing in us. Really appreciate it. Mr. Julius Adesun, so if you are up for it, you can ask the questions.
Okay. Good afternoon, everyone. Thank you very much for the opportunity. First, many thanks, Oga, for this insightful presentation. So my question is around, I'd like to hear from you, your own view, the challenge around the hardware that house some of the conventional software we use, and also bringing in either Python language or whatever. So now the challenge is where we've not been talking around the capacity of the hardware, because you agree with me that it's not every year all employers tend to change their employee system and all of that, and then the running time on some of these machines then become a challenge, even with the conventional software we're using, because of the size of the data. So in your own view, how do you think this can be managed at this time? And looking at it, that everything still boils down to cost, as you mentioned in your presentation. So we still have to save cost in one way or the other. So I'd just like to hear from you on how to manage challenges in the area of time efficiency for running some of this application. Thank you.
Thank you, Julius. That's a very good question, and I like that because I'm a hardware specialist also. And one thing I found out in hardware, I used to build machines in those days when I was younger. Now, one thing I found out is that machines are getting cheaper and cheaper. Hard drives now, yeah, they come in, they come more or less one for a penny, 8 terabytes, 10 terabytes. I mean, they're all getting bigger in sizes and they're all getting cheaper. And the machines we are using now, also the laptops and PCs, they have gotten far, far better and better. I mean, you have Xeon machines now that can take more than 256 gig of RAM, and then with maybe 8 terabytes of hard drive. and then the processors are getting faster and faster. So it's an area also that is evolving, and the evolution is make me taking cognizance of the fact that there is more machine-driven processes coming. I mean, like I said, everything eventually is going to be machine-driven. That's where we are going now. It's going to be machine-driven. Yeah. So I'm happy that that sector, is coping. Yeah. So it shouldn't be a big challenge. But the major challenge is in educating our managers or our management on the right place to put the money, right place to invest. Yeah. I mean, I will invest in bigger and bigger machines. Yeah. For me, for example, in bigger and better machines to run my processes rather than put the money elsewhere. Yeah. I know there are a lot of other things contending anyway for the budget. Like I said, security, this, that, containing staff emoluments and all this. But a good company will invest in what generates, or what speeds up the entire process and increases the production. So that's where hardware, software, machine learning, all those things, the technology comes in. In a company like ours, you cannot downplay the impact of technology. So I will put my money there, and it will be do us good also to find a way of informing our top management that look, this is where we should be investing our money. Things are changing. Yeah, nobody wants to do seismic interpretation by hand or by this anymore. As time goes on, everything is going to be, it's going to be seismic volume based. Your 3D modeling, seismic interpretation is going to be machine driven. Yeah, machine driven, and that's the way it is. So I would want us to advise our top managers to put their money, in the right place. Thank you.
Thank you very much. Thank you very much, Mr. Femi, for that. Thank you, Mr. Julius, for that question. Wow. So our facilitator is not just a guru or a geoscientist, he's also a hardware specialist. Wow. It is getting better and better. Getting better and better. Now, we'll take it to Godwin Opeku. Godwin Opeku, go ahead with your question, please.
All right. Good afternoon, Mr. Olufemi Adepoju, and thank you for that beautiful presentation from you and your team. Actually, mine is not question, but just you in your concluding remarks, you talk about collaborating with universities and research institutes. So I just want to know how are you going along with that? Because I, for once, I'm actually working on a topic very close to what you just did now. So I don't know if you're willing to take me on, or perhaps collaborate with me. I wouldn't want to use the word collaborate, just to help. And my topic is identification of bypass based zones using machine learning and seismic facial classification. So is it possible for you to give me a helping hand in developing or working on that research topic? Thank you.
Well, I'm happy to hear that. Thank you very much. It is very, very, very possible. Why? Because we have our own software called Geographics, which we market and deploy in Nigeria, actually in the whole of sub-Saharan Africa. We currently have machine learning algorithms in Geographics, and when I was making my presentation, I made mention that the service providers, including us, going back to the drawing board to come out with more more powerful algorithms in terms of seismic interpretation, Fashi discrimination, Fashi classification, and all those things. So please get in touch with me outside this meeting. You can get my email address and phone contact from the coordinator of this presentation. He will give it to you. Get in touch with me. We are collaborating with the universities by deploying this software also free of charge, yeah, so that they can learn, and benefit from these tools. So if you are still in school or whatever, let me know. We can give a license to your school and then provide some technical support to you so that you can apply it, in doing your project. So that's one of the areas where we bring in technology in collaborating with the universities. Thank you.
Yeah, thank you very much, Mr. Olufemi. That is heartwarming. Thank you very, very much, sir. I appreciate it.
Okay. Yeah.
Wow. Thank you very much. Uh, so we are also in that facilitator is not just any kind of person. It's so one of the people who speak, so giving different giving us so people will be among us to benefit from the interaction between um, the industry and the academia. I was going to ask that question at the end of the program, but Mr. Peku beat me to it. Nice one, Mr. Peku. Nice one. Thank you very much, Mr. Femi. So we have Abdullahi Abba Adam. Please go ahead with your question.
Hello. Well, good afternoon. Mentor, thank you for this wonderful presentation. We really appreciate your time and kind gesture. My questions is that I need more on that data analysis. I need to know more on how to do data analysis with this AI machine in an industry. Thank you.
So data analysis, like I said, we basically mean how you segment your data, how you classify them, and how you put like with like. So basically, before you push in any data into the model, it's good that the data is arranged in a very clean manner. Work on them, make sure the application won't mislead the application. Separate the grains from the chaff, and then put things together. So it's a lot of work here. That's why I said the AI industry will even employ more people than what we have currently, because data analysis is one of the foremost and the biggest part of it. You need to treat and condition your data properly. Yeah. Look at seismic, for example. If you do not have a good quality seismic, yeah, or seismic that is in various format like near, mid, and far, or whatever, the model will not be able to do much. Yeah. And like we have said, the more the data you have, the better. But your data need to be conditioned in such a way that the machine will make money out of it. So it's a lot of work, and there are several applications you can use to get your data organized in a decent manner before you feed it into the system.
Okay, thank you, sir.
Yeah.
Thank you very much, a friend in the north. So Abdullahi, I believe the reply Mr. Femi gave you is satisfactory. Really appreciate Mr. Femi for that. So while
Yes,
Mr.
sir.
Femi was
Thank you.
also presenting, he, he made a good part of the presentation on populating this data, where he talked about the size and the availability and also the accuracy of the available data set. Now, that the data set you have in order for you to train your models is something that need to be accurate because like you said, garbage in, garbage out, GI, GO. If you put in a wrong data set, you will get a wrong result. And I mean, the amount of time, energy that is being invested into this program, I mean, we wouldn't want it to go just like that. So the accuracy of our input data is very, very important. Training of our model is also very, very important. So with that, I will take Victor. Victor, your hands up. Please go ahead and ask a question.
Okay, good day, everyone. I'm Victor. Thank you very much, sir, for the presentation. Thank you, everyone, for attending to. So my question goes this way. My question is, sir, we all know that the world is transiting into AI now. Everything AI, not just geoscience, everything. Even we are building smart technologies, smart things now. So, sir, I want a career advice, like for us that want to trust. It definitely will have to do that because the world now is going into AI. So I want a career advice for us, we that we are still in school presently. And even if there will have to be space for more people, at least there's a level of knowledge we would have to be in that space. So I need a career advice from you, sir, and every one of us. Just advise us, just a career advice in transiting into this AI. Thank you very much, sir.
Well, the answer to that is simple, but a little bit complex. It's just like standing on a moving wheel. You can't. You have to keep. Moving also. I used to program in C++, in my earlier days, and I thought that was the end of it. And then somebody told me Python. I thought it was a snake. They say writing in Python. I said, what is that? So it's a never-ending learning process. Yeah. This day you stop learning, that's the day the whole thing ends. So initially I refused. I said, no, my C++ will do it for me. I don't want to go and learn Python. But from my presentation today now, you have seen that Python is number one. And I was telling myself, look, I got to go learn this thing. So I will advise you, get on board. Well, no knowledge is wasted. None of these coding algorithms is wasted. But I think Python is easier. Maybe because I haven't tried it, I'm yet to be convinced because, like I said, I used to be an enthusiast of C++. But like you too, I will jump on it and see in my free time what it's all about. But for you, please come jump on board. There are a lot of training going free of charge online, Coursera and all those ones. I think they offer some free courses, take some courses in these programming languages and try a couple of things yourself. Yeah. So that's the way to go. That's the advice I will give. A couple of my colleagues, yeah, I must even tell you this, a couple of my colleagues who left the oil and gas industry, anyone want to come back to the industry, what were they doing? I asked them, oh, we are learning cybersecurity. We're learning, all these IT things. I mean, these are guys who are above 50, above 60, who have left Shell and Chevron and wherever. They've gone back, took online courses, and they are doing cybersecurity and all these programming things. So that's why I keep saying, that's why I say that it's a never-ending learning process. So that's my advice to you. Jump on board, pick up one or two skills, go online, train yourself, and then get on board. Thank you.
Okay, thank you very much, sir.
Great. It's a very great, beautiful question. So let me see it. Motivating, we should work, train, work, meaning that improvement is on a daily basis. As we grow, we learn. We learn every day. There is no ending to learning. Even our elders that have been in the industry, the subject matter experts, are still coming back one way to be in the industry, finding one way to uh, provide value, to be useful and relevant to the society. How much more we, the youth, in APYP in particular, what are you doing? Mr. Femi has also said that we can make use of the internet, make use of Coursera, there's also EDX, there's Allison, all these online um, training centers you can use once you have access to your internet. There's also the NAPI YP technical session like this. I know that we have other programs lined up. So be interested, take your time, develop yourself. Thank you, Mr. Victor, for that question. And if you have any other question, does anybody come with any question? Check the group chat. I believe I saw a question there. Okay. So if you have the time, someone asked the question of the meeting, said, how are the data in the training models? Mr. Femi, please.
Sorry, I didn't get that question. How deep are the training? Something to do with training?
Okay, so I'll go ahead. How secure are the training these models?
You are breaking. How simple are the training programs or something?
Sorry, sir. Let me help. If my network is better, how secure are the data used in training these models? That's the question, sir.
Okay, how secure are they? Well, it depends on how you handle your data. So you will provide the security. A lot of clients don't allow us to put their data on cloud. I mean, with cloud, you can go buy space and put the data there and do it. But because of data security, a lot of companies say, no, we don't want, yeah? And then some of them will give you their own storage space, yeah, and they will insist you password protect it, yeah. Data security is a big issue in the industry. I hope you heard the other day there was this rumor that was it a government agency, NIMC or whatever, was selling data, personal information of people, and collecting big money for one thing or the other, and that became a big worry. They came out denying that they didn't do it. So data security is a very important aspect, and some of our clients insist before they give us a project that we demonstrate that the data is secure with us. Like I said, most of them don't want data on cloud. Yeah, people might hack into it and whatever. And then some of them will give you their own external drive and then password protect it. So it's very important. So for me, data security depends on the way you handle it. If you do not pay good attention to it, you run into a lot of trouble. That's just it. Thank you.
Very much. I think for now, presentation, count, wonderful. So if you could stop the screen, I have a share. It's time for points.
Good afternoon, Mr. Femi. Good afternoon, everyone. Can anyone hear me?
Yeah, I can hear you. I can hear you. Good afternoon.
Thank you so much, sir. I'm really privileged to have you on board to share with us your insights and experience as regards to AI in the oil and gas industry. Mr. Femi is my mentor, my power good Oga at the top. So I was talking when I reached out to him and volunteered to share his experience with the YPs, and it's a great honor and a great privilege to have him on board. And I know from the presentation so far that we've learned so much as regards to AI in the oil and gas industry, and tech is going everywhere. It's not just affecting the financial sector or the health sector or the business sector, it's affecting the oil and gas industry. And so we as geologists need to be able to align with that new drive, new trend in oil and gas industry, but you have to be tech savvy. Gonna be days whereby we generally just stick with field work and just office work or just normal processes work. Now we have to think about school methods, mathematical methods, programming, data analysis, AI, machine learning, neural networks. So all these things help to boost our productivity when it comes to producing excellent results from our starting data or wall of data. So this is actually a very good topic that was given to us by Mr. Femi, the MD of Ratio. And I know every one of you have been on this call following things. I've actually learned a lot. I myself actually I've been on the call. I've learned so much. And our advice, if you have any, if you're going to any project as just AI or you need more career advice, he's the best person to reach out to, even if company can actually support you in terms of this research, as using this software called Geographic. So on behalf of Nape YP community, on behalf of the technical team for Nape YP, and also on behalf of Nape Association, also a very big thank you for giving us your time, making yourself available to share your experience with the young professionals. And so thank you so much, and God bless you so much, sir. Yeah, that was it for me. Thank you, sir. Thank you.
Thank you very much, Flora. Thank you very much.
All right. Okay, so I would like to say, Madam Bichi, thank you so much for moderating this session and also for coordinating it. At YP, we tend to give our young professionals the ability to volunteer to moderate and something like this. And so I want to say thank you, Madam Bichi, for looking at the time, giving yourself a volunteer for this and being a moderator for this session. So if there are no more questions, I'd like to just take the announcement for our YP. So basically, next week we're having another presentation on leadership series. That'll be natural leadership series part 3. We're bringing someone on board. So just look out for the advert when it's ready at the various WhatsApp groups, whether it's the YP community group or the students, APG students community group. And also, if you want to pay your dues, please kindly pay your dues. If you want to do the membership, kindly do so. And this helps to keep the association going and moving well. Thank you so much for making the time to join this presentation, and do have a wonderful weekend. Thank you.
Thank you very much, everybody. Thank you for listening. Thank you for attending. Like I said, any one of you can reach me through Flora or through the coordinator of this meeting. I'll be very, very glad to offer support, to offer advice, and if need be, to guide in your training and career choices. Thank you very much. I look forward to having another session with you guys in the nearest future. Thank you.
Thank you very much, Mr. Femi Adip, and YP lead Flora and Mutubi. We thank the entire team. We thank the association. We thank our audience. Thank you very much. We hope you tune out to the next technical session, and also don't forget to pay your dues to the association. And don't forget the 42 Nape Annual International Conference and Exhibition is coming up November 10th to November 14th, and the theme is resolving the Nigeria energy dilemma, energy security, sustainability, growth, and affordability. Which from the interactions we've had, we can draw a link between Mr. Adepoju presentation and see pretty sure we can see that these meetings have a connection with the team, building up from November 10 to 14. All right. Thank you very much, everybody. You have come to the program. Thank you. Stay safe. God bless you all.
God bless you. Bye bye.